Any developer who is into object-oriented programming will be very familiar with the new keyword. Some others will be very familiar with the delete keyword. In this tutorial, we're going to be talking about memory management in C++. We're also going to be looking at the malloc and the calloc functions as we have them in C++. Let's dive into this video and see what these concepts mean and how they affect our program. Thank you. Good day everyone, my name is Oguchi from Beaverman Technologies, and in this tutorial I'm going to be talking about memory management in C++. Memory management is a concept that manages the allocation of memory to reference data types like arrays and objects in the heap. As we know, array data in C programming are homogeneous. That means they are of the same type, and the size of the array is determined at compile time. This makes the memory allocation static and unexpandable at runtime. But let's see how we can make this dynamic. Let us take a look at our code on the screen. If for any reason the size of our array is not known before the code is compiled, this generates a problem, because if we hover right here on the array, we're going to see that the value or size of the array is 5. We have it here, and this makes this to not break. And once this 5 is stored in the program, then we can now be able to run this for loop successfully on the array. So of course, if we run this code, it's supposed to generate the required adequate result. Now, for us to be able to dynamically allocate memory in our program, we can use the malloc and the calloc functions. Let us see how this works. So I'll come into our program, I'll declare int, declare the size of our array. First thing I'm going to have to make sure is that it's the user that specifies this size. So I'll say enter the array size. So the only time we're going to have to see this prompt is when we are at our runtime. So we can go ahead and see that it is the user that specifies this parameter. So of course I'm going to do cm, and I'm going to send whatever value into size. Now I'll go ahead and create an integer pointer called ERR. So I'm going to exclusively state that our array is going to be a pointer. Of course, let's call a malloc function. A malloc function is going to take in the size of the array that is being specified by the user, and also the size of the data type. So int or integer, for instance. Now this malloc is going to return a void. So let's go ahead and typecast or cast whatever type returned to an integer. So I'm going to go ahead and say int, an integer pointer. Sorry. So I've casted the return value of the malloc function to an integer pointer, and therefore our value should be correct here. So I'm going to also check if I was actually allocated a space in memory. So I'm going to check if my array pointer is null. So this is to check if we are actually allocated a space in the heap. So of course, if we are, we can go ahead and say for. I'm going to assign a value to, say if it's less than size. I'm going to implement that, and then I'm going to go ahead and assign a value to each of this size inside of the array. So I'm going to say enter a value, So once I have that prompt, so for I, so I'm going to place my spaces rightly. I'll say end L. Now, whatever value passed in, we're going to pass it into the current array iteration. So say I. So after this, then I can go ahead and print out the whole value. So I'll say 4 print I is equal to 0. So I is less than size. So this is just to print out everything that we have inside of our array. Say I plus plus, just to print the value there. So all we're going to have to do here is to see out array the current value at the iteration. So I'm going to go ahead and say ARR there and print out I. So the last thing we're going to have to do at the end of this program is to free that memory. So I'm going to call the free function, or free the space that was in, or to deallocate anyway. That is the word to use. So you have to deallocate the memory that's been allocated to us from this malloc. So I can go ahead and run this code. If I have a symbol for this end, I'm just going to go ahead and fix that just now. So it says enter an array size. So I'm going to enter 5, the size of my array. So the value of 0, I'm going to put in 10. The value of 1, I'm going to put in 41. The value of 2, I'm going to put in 23. The value of 4, I'm going to set it at 5. And then the last item there should be 30. So of course it prints out that value, 20, sorry. It prints out that value nicely to us on the screen. So that's exactly what we asked our program to do inside of our if statement. So it checks if I was actually allocated any memory, and if I wasn't allocated any memory, this is going to be a value, but if I wasn't allocated, it's going to be null. So if I was allocated, it's going to be a valid value. So also I can use the calloc function in this case, and I'll say calloc, and the only difference I have to face now is that I don't need to specify this multiplication happening here. So this is going to happen inside of our function. So that's just the only difference between using the malloc and the calloc function. The calloc function is going to take in a count and a size as specified here. So we run this code, and then we can see that we get the same result. So let us say the first value is 61, the second value is 26, third value is 71, fourth value is 30, and then the last value there is 6. So of course you can see this prints out very nicely to our screen. Now we can modify this code using the most recent new keyword that we have inside of our program, inside of C++. So I can go ahead and say new there, then I put an int, and then the size of our int. So I'm just going to specify that this is size. So this is going to go ahead and help us to do that. Instead of writing that very long line of code, this is going to replace and help us to do this even more easily. So we're going to have to achieve the same results from here. And instead of me going ahead to call the free function, I can just say delete. I'm going to delete the brackets there that are. So this is also a very convenient way of allocating and freeing memory inside of C++. So if I go ahead and run this code, so of course I can also state that I want 5. I can see the first value is 10, the second value is 25, the third value is 63, fourth value is 51. Just placing these values very randomly, and of course we see that these items, the numbers get printed very nicely to the screen. So this is how we can be able to create dynamic arrays inside of C++. So we have nothing to worry about in this code. This code is very, very nice and good. So in case, let's say we want to determine the size of an array based on the user inputs, based on some other variable at runtime, then we can go ahead and do that even before, after the code has been compiled. So this is a new feature. This makes a lot more sense, and this helps us to be able to write better code for our C++. So thank you for your time, and I will see you in the next video.